Today, for my project, number 3 of Precalculus, I will be teaching you conic section from expanded equations, ellipses. And what are we going to, by Ronald Tran, at the side, let me add it, so, what we are going to do today is turning a general expanded equation and identify it as a conic and turn it into standard form by completing the square. So first of all, we need to understand tips for identifying an ellipse. First of all, both x and y are squared and they have the same number of coefficients, and the same number of coefficients are actually circles, and then because some people get them mixed up easily since they have the same x and y squared, but likewise different number coefficients, positive coefficients, can show you that it is an ellipse. So here are some definitions that the viewer needs to understand. First of all, a conic is a plane. A conic is a plane curve line pair of intersecting lines. Or a point of intersection sections of bounds. There are 4 types of conics. There is the ellipse, circle, hyperbola, and parabola. And today we will focus on ellipses. So furthermore, an ellipse is a type of conic that we are learning today, and it is a closed curve. The intersection of a right circular cone. That is not parallel to the base, the axis, that is not parallel to the base, axis, or element of the cone. Next, I need to define the standard form and the general form so we can understand what is it that we are doing today. First of all, the general form is what our problem is going to be, and then we have to turn it into the standard form. Before adding more depth to that, I need to define those terms. The standard form, of the equation of a conic section is okay. The general form is the standard form of a conic section written as a b x y squared plus cy squared plus dx plus ey plus f, and the standard form of an ellipse. Might I show a picture so it might be easier instead of me writing? The standard form of an ellipse should be this, and the reason why we want the standard form is because over here, this shows where our vertex is, and this shows where these two is where our h and k is, and which is our vertex. Then it also shows where our length is. Oops. And to solve for this, we are going to complete the square. As said before, the reason we do this is so we can graph it easier. Unlike this, it will be way harder to graph. And now we got to the basis of the equation, the basis of the lesson. Let me also describe standard form, which is completing the square, which is the order, which is the method we will be changing into general form to standard form. Completing the square is writing a quadratic in the form of a squared bracket and adding constant if necessary. So if we have not learned this before, an example of this is x squared plus 6x plus 7. I was taught this way, so -7 on each side, and then we can x squared plus 6x, and then for the constant we would put b over 2 squared, so that would be 6 over 2 squared, which is 9. And since we added the constant, which was not part of the equation, we have to add it to both sides, and then that'll be 2 equals 2, and then we would factor it as normally, which I would do when I erase this, and that would be x plus 3 squared, and that would be completing the square, equals 2, and that's how you complete the square. Okay, moving on to our lesson, we will finally get into how is it that we convert equation of an ellipse from general form to standard. And over here we have our equation, which I'm going to write down: x squared plus 5y squared minus 8x plus 30y minus 39 equals 0. As I said before, this is the exact form as from the definition. Even though the definition said it was standard form, it was the dictionary definition as general form. As I said before, Then what I do is I would add 39 to both sides so we can complete the square with both x and y, and then that would be x squared. And then, as I did before, to speed up the process, I can complete the square. Wait, I can already add the constant, so that would be minus 8x plus 16, and then 5y squared. Actually, I can factor this more, so that would be 5y squared is minus 6y plus 9. And since I added this to the equation, I must do it on the other side. So then plus 16 and plus 40, since this we added 9 times 5, that's 45, and that would be 61, 100. Wait, 151, 61, yeah, that would be 100, and then let me check. And then we continue on with completing the square. X minus 4 squared plus 5 minus 5y, 5 times y minus 3 squared. And then I would do the same thing, which is to get it back to 0, divide by 100. And then this would cancel out to 20. And that is how you do it, by completing the square. And then from this we can find out that the vertex is 4 and 3. And that will be it for today's lesson. Thank you for listening. Adding on, and this is how you get an ellipse from the equation. So this is our equation. We know the vertex is at 4 and 3, so let's make it how we find the length and the width is that we radical these two, and then we get 10 and 2, so we know it's going to be 2 tall and 10 wide. So for 3 it will be 2 wide, 10 tall, let me add more, 1 2 3 4 5 6 7 8 9, 5 wide, 5 wide, and 1 2 3 4 5, and that's our ellipse. 2 tall, which is divided by 2. Okay, and that's how you find an ellipse. To recap, to get the vertex, you solve for x right here, and that's 4, and that is 3, and then the major and minor, you radicalize them to find the length and the width, and yeah, that would be it.